Hi all, I'm Vijayalakshmi, working as an assistant professor, part-time internal research scholar in Faculty of Engineering and Technology, School of Computing, SRM Institute of Science and Technology, Katangulathur, and my paper title is Enhancing Resource Management in Fog Cloud IoT Systems with Deep Learning Based Task Allocation. My paper ID is 36396 and it was accepted in the International Journal of Electrical and Computer Engineering. Overview of IoT. The Internet of Things refers to the network of interconnected devices that communicate and exchange data over the Internet. These devices will range from every household items to the sophisticated industrial tools, and the devices generates vast amount of data which enables the real-time monitoring and decision making. It also facilitates the automation in various sectors which enhances the efficiency and productivity. In overall, this IoT contributes to the development of smart cities, home automation, industries, and also in improving the quality of life and operational efficiency. Fog computing. Fog computing extends the cloud computing capabilities to the edge of the network that brings the computation, storage, and network closer to the data storage. By processing this data closer to the source, fog computing will minimize the latency, which is crucial for time-sensitive applications. It also reduces the amount of data sent to the cloud, which in turn will the bandwidth usage will be optimized and cost will get lowered. The local data processing can enhance the security by reducing the exposure of sensitive data to the internet. Now we know what is IoT and fog computing is. What is the use of this task scheduling in IoT fog environment? Efficient task scheduling ensures that computational resources are optimally utilized. Computing resources means the CPU, memory, or these are the computational resources available in the environment. Many IoT devices are battery powered. So the energy consumption has to be minimized, which is critical for prolonging device life and reducing the operational cost. Effective scheduling helps to meet the quality of service requirements such as latency, reliability, make span, which are essential for user satisfaction and application performance. The IoT and fog computing environments are dynamic with devices frequently joining and leaving the network. This efficient task scheduling adapts to these changes, which ensures the consistent performance. So in overall, this task scheduling helps in the IoT and fog environment to maintain the quality of service requirements. The challenges in the existing algorithms. So in this task scheduling in IoT fog environment, we face many challenges in the existing algorithms such as inefficient task placement, static decision making, quality of service parameter consideration is limited. That means in one algorithm only the latency will be considered, or in some paper the latency and other parameters, quality of services will be considered, and these are the main limitation challenges which we are facing in the existing algorithms. And also we have the challenges like energy consumption trade-off, lack of adaptability, scalability issues, and complexity of multi-objective optimization. So among these, the problem which I have taken for my paper is the more advanced and adaptive algorithms are needed to enhance this task placement decision in dynamic fog cloud environment to improve the resource management and system performance. The objective of my paper is to implement the hybrid approach of parametric task categorization algorithm and multimetric forecasting model, which in turn uses a deep deterministic policy gradient algorithm for efficient task scheduling in fog cloud IoT systems, and also to optimize the resource utilization and energy consumption while enhancing these system performance in the fog cloud IoT systems. The proposed methodology. The proposed methodology introduces the hybrid approach that combines the parametric task categorization algorithm and the multimetric forecasting model. The proposed framework enhances the task scheduling in the system by effectively categorizing the tasks and optimizing their execution based on the predictive analytics. This PTCA algorithm, that means the Parametric Task Categorization Algorithm, classifies the task based on the parameters such as priority and quality of service demand and the computational needs. These are the three parameters which I have used in my proposed algorithm, and the classification informs the scheduling decision made by the MMFM, which utilizes a deep learning technique to forecast future workload trends and optimize the resource allocation. So this MMFM enhances the scheduling policy by providing real-time forecast of future workload trends and also enable the proactive resource allocation. So this hybrid approach not only addresses the limitation of existing algorithm but also provides a robust solution for intelligent resource management in fog cloud environment, which in turn enhance the energy efficiency and user satisfaction. So in overall, we are using these categorization algorithm and the forecasting model. The decision will be taken by the deep deterministic policy gradient algorithm in the multimetric forecasting model. So that will determine whether the task has to be placed inside the fog node or in the cloud environment. After the decision is taken, this decision is taken based on after the categorizing the task from the IoT devices. Then it is decided in the forecasting model. After that, the scheduling is done within the fog environment or with the cloud environment. So this is the overall architecture of my topic. So here the IoT devices are placed in the lower level. So all the IoT devices will generate a task from it. Each all the tasks are segregated as a set of tasks and it was stored in separate queue. After that, the classification algorithm, this PTCA algorithm, categorization algorithm is given for the this task is given to the PTCA algorithm, which utilizes the parameters like QoS, latency, and priority based on the task or classified to determine whether it has to be scheduled in fog or cloud. So after this, this categorization, the task is given to the task scheduling engine. This task scheduling engine, task scheduling engine will in turn use this MMFM DDPG policy, that means scheduling policy, where the decision is taken whether to assign this task to the fog node or to the cloud node. So this will in turn, whatever task has the highest priority will be given to the fog layer for the computation. So which has the lowest priority is given to the cloud layer. So this figure 2 shows the DDPG algorithm which is used in the MMFM model. This DDPG algorithm uses the model soft critic model, and here we have the target network. So whatever the fog environment is there, and the parameters will be sent to the actor and critic. After that, the decision is taken whether to give the task to the fog layer or to the cloud layer. Once decision is made, it was assigned to the fog layer or to the cloud layer. So this is the overall architecture of this task offloading approach. So then we'll see about the parametric task categorization algorithm in deep. This algorithm employs a decision tree based approach. That means this task categorization algorithm works on the decision tree based approach, which classifies the task effectively in this IoT in system. So um, this classification is crucial for optimizing task scheduling and resource allocation. First, this classification requires some input features. The input features of this algorithm are the priority level, quality of service requirement, and the computational needs. So once the tasks are gathered, all the tasks has to be these parameters has to be take considered. After that, the decision tree are constructed. So this decision tree are constructed based on the parameters which I collected for the task, iteratively. So each node in the tree represent the features, that means the priority, quality of service, and the computational reads that represents the values of that while the branches represents the values of that features. So initially the tree will be constructed with the node. Each node represents the features and the value branches will represent the values of that features. So the leaves of the tree corresponds to the categorization, whether it is a fog or cloud. So this is a construction made in the task categorization algorithm. So after completing that, we need the feature selection method. So at each node, this PTCA selects the most informative features, that means which is mainly required. So in this categorization algorithm for the decision, this selection is based on the criteria that maximize the separation of tasks into distinct categorization. Okay, so these are the three main process which is considered in the task categorization classification process. So after that, this classification, what is the classification result will be? So once a decision is built, incoming tasks can be classified by traversing the tree based on their feature values. This classification allows the prioritized task and make the information decision about the execution location, whether it is cloud or fog. That will be decided in the PTCA algorithm. So this algorithm uses two mathematical models like entropy and information gain. Right, this information gain, you use this entropy model. This information gain uses the entropy, so where the entropy is nothing but the uncertainty of the data set. That means whichever is not required, which parameter or feature is not required, which is not there in the proper order, will be taken for this entropy for the calculation. So here this information gain will give the quantity of entropy that may be saved when the specific criterion is used in the splitting feature to optimize the dataset categorization. So in this regard, this information gain is the difference between the entropy and the subset. That means whatever task we are taking, so data set we are taking, so that subset of that task will be considered, and that weighted sum will be calculated here. So based on this categorization and real data set, we'll be finding the difference between these two, that will give the information gain. Based on this entropy and information gain, the uh, decision tree is formed. Okay, which in turn will give the classification algorithm. Then we'll go with the multimetric forecasting model. So this model is is used to optimize the task scheduling decision within the environment by leveraging the predictive analytics. This model mainly uses two methods. One is predictive analytics and another one is proactive resource allocation. So in the predictive analytics, first we will consider some historical data analysis. That means historic task data are considered, and based on that historical task data, and the patterns are decided here in the predictive analytics. After that, real-time forecasting model, we are using deep deterministic policy gradient, which is advanced machine learning technique. So this this model, MMFM model, will generate the real-time forecasting of future workload based on this policy gradient algorithm. So it will and then proactive resource allocation. The proactive resource allocation uses the dynamic scheduling and optimization of task execution. So since we are using the model in the dynamic scheduling policy, we are using this DDPG algorithm, and which in turn will enhance the MMFM model. Okay, this and optimize the task execution by predicting which task will require more resources and when MMFM ensures the task are executed at the most appropriate location. This will minimize the latency and it maximizes the efficiency. So this is the main use of this MMFM model. And here we are considering two parameters. One is energy efficiency and task completion time. So energy efficiency means by utilizing the energy resource allocation based on predictive insight, this MMFM minimizes the unnecessary energy usage since all the IoT fog environment or in the battery powered devices. Improved task completion time means we are reducing the latency so that many tasks can be completing within the stipulated time, and this particularly useful in real time application for quick response and response time will be very that means the latency will get minimized and the completion rate will be high. So, and the multimetric forecast in overall, this multimetric forecasting model is utilized for by predictive analysis to optimize the resource allocation. So the main benefit of this model with utilizing this algorithms are to enhance the energy efficiency and to improve the task completion time, reduce the energy efficiency and improving the task completion time. So this is the result section. So the energy consumption, I have compared the existing model and the algorithm with the random forest algorithm, SVM, KNN algorithms. So compared to all these algorithms, my energy consumption in MMFM model using these two algorithms are um, less when compared to the other three models. And also I executed with the different sizes of tasks. So here in this graph I mentioned 200, 400, 600 or size of the task and energy consumption um, which I got as compared to other of without offloading and offloading method, and the local computing and offloading computing, and also I compared with the proposed model. So in this comparison I'm getting the proposed model much lesser when compared to the other two. So this is for energy consumption. So this energy consumption in MMFM I'm getting as a 50 units, and this is nothing but the task completion rate. So as I compared with, I'm using this MMFM model and DDPG algorithm comparatively, my task completion rate is improving. The performance improvement is shown here, and the consisting graph starts from 4 unit. From this 4 unit, the reward is getting increased at the third episode. That means at the third episode reaching 14 units, so which performance gain are increasing. This will give an effective adaptation. So this is a reward graph to show the MMFM and DDPG algorithm in performance improvement. And this algorithm, this graph shows the accuracy comparison with other models like random forest, SPM, and KNN. So compared to all the other three algorithm, my accuracy in MMFM is getting like 80 percentage, more than 80 percentage. So in this graph, we can see random forest is getting like around 82 percentage, and this MMFM model I'm getting as 86 percentage. Right. So the summary of my topic is I'm the research on enhancing resource management in this environment through MMFM has a significant contributions like hybrid approach of for task scheduling. That means I'm using the hybrid approach of parametric task categorization algorithm and MMFM, that means multimetric forecasting model, which in turn uses a deep deterministic policy gradient algorithm for classification and scheduling. So after this, the decision is made whether whether the task has to be placed inside the fog node or the cloud node. This in turn enhances the energy efficiency, and I was compared with other algorithms like random forest, SVM, and KNN. Compared to that algorithm, my energy efficiency is 50 percentage lesser when compared to the other three models, and task completion rate also improved by 89 percentage by using this model and algorithm, and predictive analytic integration is done with this algorithms. Thank you.